In this video, we're going to work through an example of solving for the specific heat capacity. In this example, we have 500 joules of energy required to change the temperature of 30 grams of a substance by 15 degrees Celsius. So when we look at our heating curve chart, we know that we're going to be changing the temperature. On the back of our heating curve chart, you can have a change in temperature or you can have a change in phase. The question says that we're changing temperature. So we're going to be using this equation, Q equals M, the mass, times the change in temperature, times the specific heat capacity. So I'm going to write that equation down. Q equals M times change in temperature times the specific heat capacity. In this case, we are solving for the specific heat capacity, so we want to make sure that this variable is on top of the equation, and we want to make sure the variable is by itself. So what I'm going to do is I'm going to divide both sides by m and delta t to isolate the Cp by itself. The Cp is already on top of the equation, so I don't need to move it. So I'm going to divide this side by m and delta t, and I'm going to divide this side by m and delta t. Another way you can think about this is cross multiplying down to the bottom. So the m's cross out, the delta t's cross out. Now Cp is equal to Q over m and delta t. If I want to rewrite the equation, I can rewrite it as Cp equals Q over m times delta t. So now my Q is 500 degrees Celsius, 500 joules, and my mass is 30 grams, and my temperature, my change in temperature is 15 degrees. So they didn't tell me I went from 45 to 60 or anything like that. They just told me what my change was. I don't have to subtract. So now when I do this on my calculator, it's very important that we understand it's 500 divided by 30, then divided by 15. A lot of students will go 500 divided by 30 times 15. Now if you want, you can times these together to get the number on the bottom, and then take 500 and divide it by the total. Or like I do, it's 500 divided by 30, then you hit equals, and then divided by 15. That comes out to 1.11 joules per gram degrees Celsius as the final answer. The joules and the gram and the degrees Celsius do not cross out, so we have to keep all of those units. And in our previous examples, when we looked up the value of the specific heat capacity, it was in joules per gram and degrees Celsius. So this is an example of solving the equation for the specific heat capacity.